Well, in the previous tutorial I showed you how to create a custom schematic library, and our circuit, the test circuit is power supply, an adjustable and a couple of fixed power supplies, 5 volt and 12 volt, and input to all of these regulators is of 24 volt DC. So the components that I created in the schematic library are a variable resistor, fixed resistor, the regulator, and the adjustable regulator, and the polar and non-polar capacitors. These are the components that I have created, and now I need to add the schematic library. I need to add a footprint to each of these components. So let's get started. Starting with the regulator. Okay, so to create a PCB library, I'll go back to the project panel and I'll go to File, New, and in the library I'll add a PCB library. Alright, so now if I show you the project panel, now here you can see that in addition to the project has the source documents, that is a schematic file, a PCB file, and then have these two library files. One is the PCB library file and the other is the schematic library file. Alright, so just like the schematic library, when you open a schematic library file, in the bottom you have the tab of schematic library. Here in case of PCB library, we have a tab for the PCB library. So we can click this, and here we can add a footprint, and I'll just give a name to the existing one, like this is the TO220 package. Okay, this is for the, let's say, regulator IC. Right, so I gave him the name TO220. The reason I am giving it this name is because the TO220 is the package of these adjustable regulators, the common package. They're also available in other packages, and let me show you at the bottom we have the technical drawing of this TO220. This is the package, and now we need to create the footprint so that we can, when the PCB is printed, we can solder these pins at those locations. So since it's a leaded package, it got leads, so we need to have holes in our PCB for the soldering. All right, so we'll use a footprint with multi-layer hole, so that these leads can be soldered. All right, so the important parameters we need here are the distance between two pins. Okay, for example, the distance between these two pins, the center of these two pins is 2.54 mm in millimeter. Similarly, the other thing we need is the width of this lead. Okay, so that the hole that we are going to leave for the soldering, the lead can easily fit in. So the maximum is 1.02. okay, there is a tolerance, so the maximum it can go up to 1.02. so we need a hole for these leads that should be bigger than 1.02. okay, 1.5 is okay, that's fine, and a little bit bigger is fine, because when you try to desolder a component because of some mistake, so that you can have a tolerance. So that's a good thing to consider. All right. Okay, so what we can do here is to place the pads for those pins. Okay, so I'll start this footprint wizard, and inside this footprint wizard I'll go next. And here's the thing, I can select the unit here. So I'll go for the metric unit, because the reason is the dimension on that technical drawings is all mentioned all in mm. Okay, so if I select the mil, then I need to convert every unit into mil. That's a hard job. So I'll save my, I'll use the mm. Okay, the other thing I need to select here is the package. Okay, so there are different kinds of packages here, and I'll choose the dual inline package. Okay, because this is the this is the kind of package where we need the holes in the PCB. So that's what the best choice here is. Okay, now here's the thing. I need to mention the hole size. Okay, and then this width and the width of this the diameter of this circle, the outer circle, that's for the soldering. There's a space for the soldering, and that's it. So I can visit that data sheet again, and here the hole size should be greater than 1.02 mm. This is something we need to take care of. So 1.02 is the minimum. I can set it to 1.5. The hole size should be 1.5 because the lead length is that width is 1.02. So I'm going to set 1.05. Just press enter. Now the other things, if this is 1.5, these guys should be greater than 1.5, so that there is a metal for the soldering. So I'll put it 2. I'll set it to 2. Similarly, this one I'll set this to 2. Similarly, here I'll set them all to 2. Okay, once done, I can press next. Okay, here the next thing is the relative position of these pads. Okay, how far should be one pad from the other? The center to center distance, distance from one center to another. And I'll go back to this data sheet, and here the distance between this center of this lid and this lid is 2.54 mm. Right, so 2.54 mm. The important thing here is in case of that hole size, I had tolerance. I can even I can match the I could have set that to 1.4 or 1.45, but here when it comes to the distance like this between the two leads, we cannot it doesn't offer any tolerance. So we need to strictly follow this and type in 2.54. Okay, I'm ignoring this distance here at the moment, and I'll tell you why I'm not interested in this distance. Okay, in just a moment. I'm going to press next, and then it says that the outline, the external boundary that's it's going to create using the length of that line is going to be 0.2 mm. Okay, that's not important, and I'll say okay, yes. All right, here's the thing that I can set the number of pads, the total number of pads, and here you'll see that I can set it to even numbers, like 3 on the left, 3 on the right, 2 on the left, 2 on the right, or 4 on the left, 4 on the right. I can set it to even numbers. Okay, so here's the thing. The reason I ignored that other distance was between this pad and this pad. Now my intention is to because my regulator is a 3-pin package, so I'll keep only the 3 pins on the left, and I'm going to delete the other 3 on the right. So I'll set this to 6 pins, 6 pads. I'll use 6 pads, and out of those 6 pads I'll delete the other 3. Okay, so that's why I said that the distance between that pad and that pad is not important. All I was interested was the distance between these pads, among these pads. Alright, so now I have set this to 6. I'll press next, and I'll call it DIP6. Alright, for the moment it's okay, and finish. Alright, so now you can see I have a 6-pin package. That's normally for an IC, and I can get rid of these 3 and also this outline. I can also remove this outline. I'm not interested because it's for an IC. So these are the 3 pins I'm going to use for my regulator IC, and I can also rotate them by selecting all of these 3. I can create a rectangle selector, and then I can click somewhere so that it's in the dragging stuff, and then I can press this space bar to rotate them by 90 degrees. So that's our that's the footprint for the regulator. Now here's another thing to confirm whether the spacing is okay, whether the hole size is okay or not. We can confirm that by adding a 3D model to this, and we'll see that whether it fits, the pins actually fit in these holes or not. So for that, to find a 3D model for this, we'll visit a website that's a free database for 3D models, and that's the 3dcentral.com. This is an excellent website, a free database for 3D models. So I can type in 3dcentral.com, and you can subscribe to this website for free. You don't need any. It's free. You can sign up and create your account here, and then you can sign in here. I have already signed in. So you can sign in and then search the model. For example, TO220 regulator. So here I'm going to search for the regulator, and there are several options here, and I'm going to choose, let's say for instance I'm going to choose this TO220 package. Alright, and then we'll choose something that we can import easily, and that is the step. Okay, the step model. There are different formats, and I'll recommend you to use the step model. Here the other thing you need to consider here is that you'll see a zipped option here. If it is checked and you are unable to uncheck this, it means that this model will be available, this model will be downloaded in components, and you'll need to put those leads at the right place to synthesize this 3D model. So if I see this situation, I'll back off and try to find another one, because it's a hard job to find to place those components to the right place. So I'll go for another one, and now I can again choose the step model here, and then I'll choose AP 2003, and here you can see I can uh, uncheck this zipped option. So now I can download and click this link. Alright, download. Okay. So now it has been downloaded. Now I can come to place 3D body, and here is the shape that I have just downloaded. Okay, so for the first time you'll see this shaded pink box, so you can place it somewhere, and you can also place it multiple. You can also place multiple copies of it, but we just need one, so I'll just delete the others, and when you want to place only one, just click once and then press escape. Now select and then come to properties, or before coming to properties, press 3 on your keyboard, and you'll probably, it's kind of, the color is not very clear, but you can make it clear by press 2 is the two-dimensional view, press 3 for the three-dimensional view of this 3D shape. So select, and in the properties I'll recommend to change its color. Let me a little bit darker, and again I'll choose this and override color. Okay, now I think you can clearly see it. Okay, but the thing is, if you want to rotate this shape, because you are in three-dimensional, just press shift on your keyboard and use your right mouse key, the right mouse button on your mouse, and while holding your shift key, and you can rotate it in 3 dimension. Alright, so now press 2 again. Okay, now here's the thing, in order to match in dimension, let me show you. If you place it here, press 3 again. Here are your pins, and they are not in the right alignment, so this guy should be the 3D model should be rotated so that it can fit in into those pins. So I'll rotate it by along the X direction by 90 degree, and now I can again press shift and right mouse key, and now they can probably go in the right direction. Okay, but the height is not appropriate, so I'll again choose this shape, 3D shape, and I'll use a standard height of say 7 mil is quite small, because I have changed the unit. You can use the unit, the type of unit you can change by just pressing Q button on your keyboard. I have pressed Q. I can you can see that it's now in the millimeter. The unit is now millimeter. Okay, so there's a standard height now, and now we can check whether the 3D model is going to fit in or not. I'm going to zoom in. Alright, so I think it's okay. As you can see from here, it's okay. And yeah, it's perfect. All the three pins are perfect. And that means that we can use this footprint for the regulator IC. Alright, now we need to define a boundary of this regulator IC, because if you don't mention, if you don't specify a boundary, it misguides you while tracing the PCB. The reason is, you can see that when you solder your IC, it will take this much of space. According to the 3D model, according to your 3D model, it will to occupy this much of space from your on your PCB. Right, so this is the right, this is the boundary. Okay, we need to respect this boundary. We should make sure that none of the components on the PCB is inside this range. Okay, because we know that once the once the regulator IC is soldered in, it will take this much of space, so you cannot place a component within this boundary. But if you are trying to, if you want to put that IC on the top, you can then put another component inside this boundary at the bottom. Okay, so you can put it at the bottom but cannot on the top. So that's why we need to uh, we need to specify this boundary. Okay, so this is a two-dimensional view, and now you can press 3 to get into the 3D model. This one is better. Okay, so with that said, we are done with our TO220 package, 3-pin package. And okay, another thing I would like to mention here, that the first when your PCB is printed, we we are not quite sure about if all the holes are like this circular, so it makes you blank while soldering, that whether which one is the first, which one was 1, which one was 2, which one was 3. So making the first one square gives you an idea that the pin numbering is pin numbers is started from here, then 2, then 3. Or you can place a text here to make it even more clear. Let me, in properties, I can type in I, let's say for input, and we can reduce the size a little bit. Can press 1. The text height is 1. The text stroke is, maybe I can reduce it to 1.5. Okay, even the 1 is quite big. I can set it to 0.7. So I can write it here, I can place it here as I. Similarly, I can copy and paste here and name it G for ground, and then I can copy and paste again and put it here and name it out. Please note that everything in the yellow is on the top overlay, means that they are not anything conducting. It will be printed on your PCB, and just to make your life easy, here it just displays like a drawing. So you can use the overlay layer to make things easy for you. All right, so Okay, please make sure that on the schematic library that the pin number, the mapping, all I mean is mapping, like you have number 1 here, this pad, and 2 is at ground, okay, and the 3 is at the output. You need to confirm this. Even if you have numbering like 3 to 1, that's okay as long as you have the corresponding pad numbers at the right place. So now I can save uh, my library. We name it a consistent consistency regulator library, but it's a PCB. Okay, this is a PCB library. We have a schematic library, so this is the PCB library now. And once we have the PCB library, we can assign a footprint to this schematic library. Just go to add footprint and then browse, and here now you can see we have this TO2203. We can use this packet, then press OK, OK, and now you can see you have a footprint here added here. Okay, so now the regulator IC, the fixed regulator IC, the package is complete. You have a schematic symbol for this guy and also have a footprint for it. So you can use it now for the schematic and PCB files. Okay, let me add another component to the schematic library, to the PCB library. Sorry, we have PCB library here, and again go to the PCB library, then add another one. You can this time I'll try to create a custom one. By custom I without using the app wizard. I'll try to show you how you can do that. And I'm going to create a package for the capacitor, for the polar capacitor. For the polar capacitor, you can search first on the Mauser or DJ key. I'm going to find the capacitor for the input side, and that's going to be quite a kind of bulk capacitor. I'm using a 47. I'm looking for a 47 microfarad tantalum capacitor. So I'll just scroll down. I have 22 and 50 volts. Since the input is a 24 volt, I'll try to have a capacitor with 35 volt or 50 volt. So there's a tolerance. And here's a 10 micro. Now I have another 10 micro, 15 micro. So we can choose one from 22. Oh, sorry, I have one here. Yeah, I have one open here. So what I need to do is to go to the package detail. The package details I need here, and first, this is important. We have two kind in this series. We have either X or E. When the X means that EIA 7343-43. This is the size, the length, the width, and the height is here. For the E series, we have this is the code, and the dimension is all here. Okay, so we are interested in the length and the what should be the length of this pad and things like that. And similarly here we can see that if we have for instance we have a 22 microfarad, and this is the package for 22 microfarad 50 volt, or maybe for the 47, even 47 microfarad 35 volt. For these guys we have the 7343 package. The case size is 7343-43. Okay, so for that particular value we need to follow the package. Yeah, so here we have the option E and X, so we need to follow this guy 7343. That's important. Okay, so here you can see from the bottom picture here we need to have a length of this pad. Okay, this pad should be, for soldering, the pad should be of 2.77 millimeter of length, and the width should be 2.55. okay, and the distance between these two guys should be 3.67. so these are the important information we need. So let's get to the, here we have X7343-43. This is the package we are looking for, and this is a tantalum capacitor. So tantalum capacitor. Okay, so now we have created a new blank schematic, the PCB library. Within library I have created another space for the component, and now I can place a pad here which should be a size, the length of that should be 2.77 and the width should be 2.55. so I'll go to this quick access bar, place pad, I'll just place one, and I'm going to press escape for the moment. Then I'll go to this property, and in the properties I'll go to top, and the top we have a multi-layer, and instead of multi-layer I'll set it to top layer, because it's going to be an SMT package. We don't need any holes for this guy. Okay, and I'll just use the designator 1 for this. Alright, now we have some other options, like instead of rectangular round we need a rectangular, and then we need the size. We need to mention the size here. You can set it here, so the length should be 2.77 while the width should be 2.55, and to confirm, 2.55 is the width and the 2.77 is the length. Okay, 2.55 width and 2.77 is the length. Yes, so this is the first pad, and now I need another pad, so I'll just copy and just paste in somewhere. I'll try to put it close to this guy. Okay, and this is going to be my second pad. I'll just name it, use the designator 2. Okay, and what is the next thing is the distance between these two. That's important, that this edge should be at a distance of s from this edge. So what should be, what is that distance? It's 3.67. so I'll just select one of the pad, this pad. I'll press M on my keyboard, and then I'll select move selection by X Y. So here I'm going to type in 3.67 mm. So it will offset the second pad to the right by 3.67 millimeter, like this. So now we can use a measurement tool for this. I can just press Ctrl M, just place dimension. Now to see that here like this. So it's in the mil. The unit is mil here. You can change it to millimeters, and it's because of this size is not exactly at the right place, so that's why it's a little bit more than 3.65. So it's 3.6867 exact, to be exact. Alright, now again, just like the other case, if you want to test whether it's exactly will it match the actual component, we'll place a 3D here, that is 7343-43. We'll place a 3D component here. So I'll just first download this guy, and let me choose the step, and unzip. Now I'll download this guy. Download. Okay. So now it has been downloaded, and I can load it to project place, and then the 3D. I'll just place it here and press escape. Okay, so now you can press 3 on your keyboard to see whether it's going to fit in or not. So you can see that it fits well on your pads. So you can see the bottom view, you can also see the top view. So this is good. So now what you need to do is to specify the outer boundary. Another thing that is important here is, since it's a polar capacitor, we need to check what's the designator here. So let me show the designators here, and that's not consistent with the 1 and 2 here. So I'll number them 1 and 2 in order to match with that footprint. So I'll just name it 1, similarly 1 here. I don't want to show them, it was just to confirm, it was just for confirmation. And then again 2 here. I'll just hide these, and now I can save it again. So you'll sometimes go back and forth between the schematic and the PCB library in order to make sure that you are going the right way. So with that done, now you need to make sure that on your PCB that your positive terminal is connected here and the negative terminal of your capacitor is here. So you need to have some kind of symbol that should remind you about this. So for that there are different ways. For example, on the top overlay, select here the top overlay, and you can bring in here a string and just type in plus to indicate the positive terminal. That's one way you can do in order to make sure that while soldering the positive is here and the negative is there. Another way you can do is, you can, while specifying your boundary here, make a okay. So now you can use this as a reminder that this side is the positive end and this end is the negative end of your capacitor. Okay, so now you can save it, and once you save it you can add this as a footprint to this guy. Now you can browse, and here you can see that your footprint is here for the tantalum capacitor. Press OK, and you can see here the footprint is added. Now just save this, and another component is also ready. Now please note that for a single device, let's say for a single capacitor, you can have more than one footprint, but you can use one at a time while while setting up your PCB. So you can add as many as footprints you want here in this list. Okay, so I have added these two components, and to add another one for your reference, I'll just add one more, and this time I will use, just delete this for the time instance, and let me get into this wizard, and this time I'll just create a resistor. I'll use a chip here. Press next, and here we have the resistor. I have a data sheet for the resistor, and I'm going to use the package information of 8030 R0805. I'll just scroll down here. Here's the detail I need. Okay, so alright, so this is the recommended dimension, solder pad dimension for the different packages. Like we have 0402, 06, 03, 08, 05, 1206. These are the different resistor packages we have here, and these are the recommended soldering pad dimensions for the SMT package. So the G, that is the distance between the two pads, it should be 0.8 and similarly the width should be 1.25. The X is the length, sorry, Y was the length and X is the width, that should be 1.5, and Z is the distance from this end to that end. Okay, so we can use this these information here. Have a look into the required package values. Okay, the package, we need the package here. So the package here is here. We need to mention the body length. Okay, here you can see the L. So the body length here is the minimum, and the maximum values are, the L is 1, that is 1 millimeter, and sorry for this guy, it's 2 millimeter, and plus minus 1, so it means that the minimum is 2.1, and the maximum is, the minimum is 1.9, and the maximum is 2.1. Okay, now the next is the Okay, we are done with the length. Now the next is the width. So the width is 1.25 plus minus 0.15. So it's 1.4 and 1.1. Okay, the range is 1.4 and 1.1. Okay. Similarly, the other thing is T, and the T is this guy. Okay, TT it is annotated here as TT, and that's zero point 0.4 plus 0.1 and minus 0.2, plus 0.1 and minus 0.2. That's important. So zero point 0.4 plus 1 0.2, that's the 0.5, and on the other side it's 0.4 minus 0.2, so it's 0.2. Minimum is 0.2. Alright, and the height is not really important. And then it's the capacitor, and the other thing, polarity, pin location, none. We don't need any polarity location information here. So next, and it says that the distance between the two guys should be, so we don't need this information, as we have already mentioned the other things. And I'll just press finish. So now you can see that it has created uh, for us this resistor package, and you can yeah, resistor package, but I have used the description from the capacitor, so you can change that too. This is R0805. Okay, this is a resistor. Okay, so with that said, I'll conclude this tutorial, and I want you to complete the other components to draw the PCB library, complete this PCB library for the other components involved in this particular schematic. So yeah, I want you to create a variable, a footprint for the variable resistor, and for the non-polar capacitor, like 1206 or maybe 0805, but a capacitor. Okay, so till next tutorial, bye bye.